All right, so now let's use those theorems to prove some, or to solve some problems here. So it says, for what value of x is the figure the given special parallelogram? Okay, so we want this figure to be a rectangle, which is a special parallelogram, right? And so if this, for this to be a rectangle, the diagonals have to be congruent, right? That's what we just proved in the last theorem. And so this would have to be congruent to this. Now, we already know in any parallelogram that the diagonals bisect one another, right? So I know that this would equal this, and this would equal this, right? But if these two diagonals are congruent, then that means that each of these segments is congruent to one another, right? So basically, for this situation, we can say that 3x minus 5 would have to equal x plus 1. Excuse me, and then we just solve for x from there. So I'm going to take away x from both sides, then I'm going to add 5. And so we get 3x minus x is 2x, and then 1 plus 5 is 6. Divide by 2, and we get x equals 3. All right, so that's the value for x that would make this into a rectangle. All right, so rhombus. So rhombus says if a diagonal bisects a pair of opposite angles, then it must be a rhombus, right? If a parallelogram has a diagonal that bisects a pair of opposite angles, so if this is the same as this, right? And if that's true, then we can prove that this is the same as this, right? Because we could use alternate interior angles and probably a few other ways too. So basically for this one, I just have to say 2x plus 39 is equal to 6x minus 9, all right? And you all know how to solve equations really well, so I'm going to let you do this, and I'll make this a question on the play pause it. All right, there's a solution if you need it, so you can pause the video and copy that down if you didn't get it, or find if you have a mistake, or just confirm if you got it right. All right, number 18. So now we're trying to see if this is a rhombus. So in a rhombus, remember that the diagonals are perpendicular to one another, right? And so if the diagonals are perpendicular, that means that these would be right angles, okay? And so if this is a right angle, that means that these other two angles here would have to add up to 90, right? Because they would all have to add up to 180, and so it would have to be, and you can do this a few different ways. You can either just say 3x plus 6 plus 8x plus 7 equals 90, because you know that there's only 90 degrees left if this is 90, or you can kind of do the full out version and just say, okay, 3x plus 6 plus 8x plus 7 plus 90, so I'm adding all three of these angles together, and that would have to equal 180, right? But you'll see very quickly that when you subtract 90 from both sides, you'll just get this, right? All right, so either way is good. So I'm going to use this one over here. And so I'm going to combine like terms. 3x and 8x make 11x. And 6 and 7 add together to make 13. So then we can subtract 13 from both sides. And so we get 11x equals 77. We can divide both sides by 11. And we get x equals 7. All right, so that if that were true, if x equals 7, that means that this would have to be a right angle, and that means that this would have to be a rhombus because the diagonals were perpendicular, okay? And remember that this shortcut that we used, if you have a right triangle, the two acute angles, the two angles that are not right angles, must add up to 90, right? Because 90 plus 90 is 180. And so those two angles must equal 90 to make the whole, to make the sum of the angles 180.